Let's continue our exploration of the components of a user-defined function. We're going to look now at environments. An environment is a space where everything is stored. Normally, we are working in the global environment. If you look down here in our pane, in which I have selected the Environment tab, you'll even see Global Environment right here above where our values and our functions are listed. There are other environments, including the environments of packages that contain functions we may not be using in our current global environment. If I pull down this little arrow here, you can see a variety of packages that are actually installed and that the libraries are available to me that I've loaded, but these packages will contain additional items within each of these environments. So if I click on, for instance, the package here, I can see the different functions that are available in the package here. Let's go back to the global environment and work off of that as we learn more about environments. We're going to look now at the environment of a function because functions create their own environment. So let's work through first a few items in the global environment, and then we're going to compare those to the environment of a function. So here is my var1 and my var2. You can see over here in our global environment that we've actually established these two new objects with the values 20 and 30. We can use the environment function to look at the environment. So if I click on environment, it tells me that right now I'm in the R global environment. That's the environment that we're using, and that's what you're seeing here in the pane is what is in that environment. But now let's create a function. Here I'm creating a function that will take any value we send it and add 15. I'm going to call that function add 15. But while I'm in this function, I'm going to do a couple things that have nothing to do with adding 15, but rather that I'm using in order to show you how the environment works. Notice that what I've done here is I have, within my function, created my var1, the exact same name I had before in the global environment. I'm doing that for demonstration. I'm going to set it equal to 100, and my var2 is going to be set to 200. Currently, my var1 is 20 and my var2 is 30. And then I'm going to print those. I want you to see what happens when I print them when I'm running my function. Notice the open curly brace. I'm still within the function here. And I'm also going to print the environment. Then I'm going to return y. Y is just x plus 15. So really the only thing that I'm doing in my function is adding 15. I really only need it this line right here. But all these other lines are to help us learn about the environment, and this one here too. All right, let me go ahead and create the function. And now let's call it. I'm going to call it with 50, so it's going to return a 65. Now here are the numbers that were printed, 100 and 200. And here is the environment. Remember that I set these to 100, my var1, and my var2 to 200. And here's the 65, that was the output. And here is a funny looking name. All this is an address of memory in the computer. And at that address is where the function is being stored. This is referring to the function environment. You never have to worry about that name. You never have to use that name. But I'm showing you the environment no longer said global environment. It gave instead this address, meaning it's in a new environment, the function environment. Now let's see what the value of our two variables are. My var1 is 20 and my var2 is 30. Wait a minute. I thought we set my var1 to 100 and my var2 to 200. All right, this is the tricky part and the important part. Whenever you're working within a function environment, which is everything starting on line 172 all the way down until the last curly brace on 189, that function environment, which is stored in this piece of memory right here, is a separate environment from the global environment. It's like if our universe we thought of as our environment, but then something happens in another universe. It's totally separate, even if it's called the same thing. So the fact that I called this my var1 100 and my var2 200 had no effect on the my var1 and my var2 in the global environment. No effect at all. Why? Because it was seen as something separate, out in another universe. And once we hit that closing bracket, guess what happened to my var1 and my var2 that was in the function environment? It went away. Once the function returned this value of 65, this memory that is indicated here as the function environment is freed up to be used for other stuff. It's temporarily an environment while the function's running, and it contains its own values separate from everything else, including the global environment. But when the function's done, it's done, and the memory is cleared out, and something else can be put in that spot in the computer's memory. When a variable name is used, R is first going to look in the current environment. If it does not find it, it will look at the next level up and the next level up and so on. That is, we can have nested environments. Now, we're not going to get into nestings beyond the function nest, at least not at this point. But let's do another example to show you what I mean here. Let's create triple add 5. Triple add 5. So it's going to be a function. We're going to send it the x again. And let's see, what is triple add 5 going to do? Well, the first thing I'm going to do is include two nonsense variables, a and b. And a is going to be set to 10 and b is going to be set to 20. Now remember, this is going to be within the triple add 5 environment. That is going to be a temporary environment. But now I'm going to create a function within a function, so I'm nesting environments. So here I'm going to have triple, a new function, within the triple add 5. I'm also going to set one of our nonsense variables to be 100, and then we're going to print both A and B. Then I'm actually getting to the guts of what triple does. It takes whatever my y is, multiplies it by 3, that is, triples it, puts it in z, and returns z. Now, once I've left that triple function, I'm going to print a and b again. Remember, I'm still within a function, but now I'm within the triple add 5 because I've hit the closing brackets of the triple function right here, but I'm still within the triple add 5. I've not hit that closing bracket. I'm going to print A, I'm going to print B again, just like I did up here, and then I'm going to take the triple of whatever the x was, which we know will call the triple function up here. It will call this function, it will triple it, and then I'm going to add 5. That's why I call it triple add 5, and I'm going to return z. All right, let's go ahead and put this function into memory. So I put this function into memory. Now, the first thing I want you to notice is this. Triple add 5 is in the global environment. Triple is not. Why not? Because it's hidden. It's within the triple add 5 environment. Triple add 5 is its separate environment. And so triple is nested within triple add 5. I'm only looking here at the global environment. I'm not looking at the triple add 5 environment. Let's run this. I'm going to call it with a 50. So 50 will be tripled to 150, and add 5, it should give me 155. But remember, I'm also printing stuff in the process. Here we go. All right. There's our final value. There's our 155 right at the end. But let's go through what happened when it printed. Let's go all the way back up here. We set A to 10, B to 20. And then after I set these to 10 and 20, the triple function's not going to run right now. That environment isn't even going to be loaded because I haven't called it yet. So we got to skip it. And we come down here, and now we print A and B. 10 and 20. Here it is, 10 and 20. And now we call the triple function. So the triple function back up here is being called. Note we set A to 100 and then printed A and printed B. Well, printing A, there it is, that 100. Print B, it doesn't see any B in the triple function, so it goes up one level to the triple plus 5 function where B is 20, and that's what it prints. So if it's available at that inner level, it will print it. If not, it will go one level up. If that's not available, it'll go one level up, all the way up to the global environment. I know this takes some thinking to get your head around it. You want to clearly understand when a variable has the same name, which variable it is that's being used. And it's going to be the one at the innermost environment. Now, the easy way to avoid problems is to use different names. But the more and more functions you write, the easier it becomes to duplicate names without even knowing it. So you have to know how this all works. So let's now review the function components. We start with a function name. It can be any valid variable name, but you should avoid using R predefined names and existing function names for functions that you have written. Try not to duplicate those. Formal arguments. They can be any R object. So we've been using X, we've been using Y, and those can stand for any object. Arguments can be given default values. And if it's possible that you might want to ever pass through an argument to another function, even if you don't need it in your initial function, you can use the 3 dots. The function body is the code that runs when a function is called. The environment defines what is seen within a function. And then finally, the return value is the object that is returned by the function.